All right, this time we are closing on algebra for A-level mathematics. So you are interested in manipulating algebraic expressions using laws of indices, logarithms, in partial fractions, you name it. So let's check what we have on the last aspect. So we're interested in simplification here. So according to our second law, when we are dividing, I think we take the common base, then we look at the difference. So this simplifies this to a to the power 4. Still moving, we have a negative exponent there, so I've got 81. I mean, negative exponent looks like everything goes on the denominator, but with a positive exponent. So this gives us 1 out of 9, because it's more like root of 81 on the denominator. Then next we have sets, and like we said earlier, with sets we're interested in perfect squares. So perfect square that I find in 18, I think it's a 9. So 9 will come out of the bracket as a 3 root 2, because it's 9 times 2, which gives me 18 plus. The perfect square that I find in here, it's 16. 16 times 2 gives us 32, so it gives us 4 root 2. And if I look at these parts, they are like, so it's as good as I'm adding 3 and 4, so that's 7 root 2. Right, moving on, I'm interested in rationalization. And when I'm rationalizing, I don't know whether it's a short code that I'm doing, the root, because we don't want it on the denominator, so it goes away, we remain with 3. Then, as it was on the denominator, it goes on the numerator, so we have 2 root 3 over 3. Then it means we have rationalized there. Then next, we are interested in simplification there. So when we check, it looks like on our numerator, it's in its simplest form, but the denominator, it looks like we can factor out x, and we remain with x minus 5. There, we have x on the numerator, x on the denominator. So in simpler terms, that is the same as 3 over x minus 5. Still moving, I've got logarithms to simplify there. When I check, this is a perfect square of 5. So it's 5 squared. So it means all that we have there, it simplifies to a 2. Then here we have 5 cubed, but the base is 5. So all that we have there simplifies to a 3. So it's 2 plus 3 to give us a 5. Right, next we have got logarithmic equation. Because we've got logs both sides, I mean, those logs will go away, end up having x minus 2 equal to 4. Therefore, x is actually 6. Still moving, we now have inequalities. And the first part is linear, where we group like terms together. So we end up having 5x minus 3x greater than minus 8 minus 2. So in the end, we have 2x greater than minus 10. And when we divide both sides here, end up having x greater than minus 5. Still moving, we now have a quadratic case where we said here we'll assume this is an equal sign. So if we can check, and there's difference of two squares, which we are saying the factors here are either x plus 3 or x minus 3 being equal to 0. So the critical points will be negative 3 or positive 3. So use my number line. Say there is negative 3, positive 3. And 0, I know is a value of interest. If I plug in 0 there, then I'm saying minus 9 is bigger than or equal to 0. It's not true. So the correct direction for my inequality will be that. So I come and conclude below that for this particular inequality, x is less than or equal to negative 3, and x is also bigger than or equal to 3. I think that's it for that. Then the last one, number 10. We are interested in having this as partial fractions. So like we did earlier, we are saying, well, there's a minus there, minus 1 all over x plus 3 x minus 1. If we partialize them, they will give us fractions where our numerator is a over x plus 3 plus b over x minus 1. Now, when we get rid of the common denominator by multiplying both sides by what we have there, we end up having one side having 7x minus 1 being equal to a into x minus 1 plus b into x plus 3. Because we have multiplied both sides by what we have on the denominator here, so that's the equation that will remain. But remember, we're looking for the values of a and b. Now, to get rid of a, we simply bring in a 0 as a coefficient of a there, then a goes away. So we are saying let x be 1. So if x is 1, 7 times 1, 7 minus 1, so we end up having 6. And there when we add 1, we have 4b. So in essence, our b is equal to 3 over 2. Then we do the same for b, because we want to get rid of b. So we'll make b negative 3. So negative 3 plus 3, b is eliminated. So let x be negative 3. So if x is negative 3, negative 3, negative 1, we end up having minus 4b. And negative 3 there times 7, that's negative 21, negative 1, that's negative 22. And when we divide both sides by negative 4, everything becomes positive, and our b will actually be 5.5, which is actually 11 over 2. So it looks like we're done there. We will now come to conclude that this fraction in partial form will be equal to a over x plus 3. So it's over x plus 3. But what's our a? A is 3 over 2. So we have 3 there and 2, then plus b over x minus 1, b. But we saw that b is 11 over 2. So 2 into x minus 1. I think this will be the fractions in partial form. I think that's all, folks, as far as algebra is concerned in A-level mathematics. Let's meet in the next discussion. Thank you.